What's up, everyone? True Techno Gamer here. Back with another cool video. It was inevitable. I had to talk about this at some point. What is going on with PC gaming? There's been a lot of stuff lately in the media, in the news, with release after release just being really, really bad, really, really poor. There's talk about 2023 being the worst year for PC gaming ever. There's a number of reasons why I think this is happening, and it's a hot topic, so I have to talk about it. Please like, subscribe to the channel, give me some comments, show me some love, help me grow the channel. I really appreciate the support. So what are some of the games that have come out lately that has seen these issues? I mean, these issues have been really escalating, and they go back to at least last year. But I mean, obviously, there have been bad PC ports and bad PC games, since the beginning of PC gaming, pretty much. But in the last year, we've seen releases like Gotham Knights, last fall, Callisto Protocol, Forspoken in January this year, Wild Hearts, Last of Us Part 1 in March, and then, of course, more recently, Jedi Survivor, and then, of course, games like Redfall that just came out a few weeks back. There's obviously way more games, in the last few, several months to the last year or so that have had some issues, some significant issues on the PC front especially, but those are just some of the highlights there. Now, when I think about, in general, why PC issues are amplified now, some people say, obviously today is the world of social media, so anyone that has a bad experience, they can talk about it on Reddit or on their Twitter or whatever, and everyone's going to know about it and hear about it, right? And then, of course, it's going to bring more people out the woodworks, like, oh, I'm running into this issue and that issue as well. Yeah, that may be part of it, but there are real issues happening here. I've heard some people say, oh, this isn't anything new. PC gaming has always been like this, and there's always been some bad ports. Yeah, there's always been some bad ports, and there's always been some problematic games, again, but not release after release after release. This consecutively, you can even look to last year, it wasn't quite this bad, right? So there clearly is, a set of things that are happening that's, it's looking like a pattern. And again, it's amplified by social media in 2023 and stuff like that. But there are some unique things happening, I think, now, today, with modern 2023 gaming on a PC that is contributing to this, that may not have been there previously. Okay, so in general, I think one of the biggest reasons why this is amplified right now is that there was a time through most of history where if you were gaming on a PC, we all know PC is a very, very, very wide set of hardware SKUs, right, that you can run. And if you were playing on PC, if you had a low-end PC or mid-range PC, limited RAM, slow CPU, stuff like that, slow GPU, of course, you were probably going to run into some issues, some technical related issues, because, yeah, some things might have slipped through the cracks in terms of QA testing from the dev, that kind of thing. But if you had a cutting-edge, top-of-the-line PC with the fastest GPU out there and the fastest CPU out there, for the most part, you can pretty much plow through any and every game and be fine. That was the case for a large part of history. And the issues that we're seeing now that I'm going to talk about in this video and highlight for you guys, you cannot power your way through them. You cannot brute force your way through them. In other words, no amount of PC power and hardware that you may have out there, thousands and thousands worth of dollars with your RTX 4090 and Intel 13000 CPU and Radeon 7800 Zen 4 CPU, whatever it is, you're still going to run into these issues, and these issues are game-breaking issues. They fundamentally ruin the experience, and in many cases, make your several $1,000 investment in PC hardware run even lower and less effective than a $500 console. And that's a problem, right? That is a problem. So that's the interesting thing here, right? So let's talk about that. Now, so what are the problems, right, that we're seeing lately? If you don't pay attention to this, I'll break it down for you. If you have paid attention to this, then I'm going to give my, insight and my takes on what I think is happening here. So the first set of problems, I'll say, let's just group them up into technical issues. And again, No amount of power can save you from these issues that we're seeing. And it's not the same thing you see on console, right? These problems. To some level, they may be there, but not to the same degree, right? Not to the same game-breaking degree in many cases. So what are those technical issues? The first, let's talk about, is the CPU performance and just general CPU optimization. Now, many games are coming out and basically are extremely CPU limited. And even on ultra high-end CPUs, the top of the line, 13900K, the 7800, XD CPU from AMD, right? Or whatever. Any CPU out there is still CPU limited. And this has a lot of adverse effects, okay? So the first thing is, if your game is really CPU limited, it's going to throttle the performance or limit the performance of the GPU, right? The GPU is only as fast as the CPU, right? The GPU has to be fed instructions from the CPU. If your CPU is bottlenecked and can't feed the GPU fast enough, then guess what? There's going to be a lot of idle time on the GPU. So when you have that RTX 4090 that you're looking to kill every game out there, it's not really going to be able to do that, right? Because you're going to be extremely CPU limited, and the GPU is not going to be running anywhere near at its full efficiency, all right? And we're seeing that. We're seeing games running on a 4090 that performs pretty close to a 3080 or something, because it's not able to really punch that much faster. The second adverse effect of CPU boundedness and limitations is it effectively negates many of the advantages and flexibility when it comes to PC settings and features. So if a game is CPU limited, a lot of those settings and a lot of the joy of the PC, right, is you can customize the graphical settings in particular, change things like resolution, change settings from low, medium, high, ultra, whatever, for all of these different graphical effects. Usually those options and settings affect the GPU load, okay? But if you're CPU limited, you will find that changing those settings doesn't change anything in terms of performance, right? So typically you might want to reduce some settings to get more performance, to get higher FPS, higher frames per second, right? When you're CPU limited, like we've seen in some of these games, you can go in and reduce the settings from ultra to high, high to medium, even in some cases even to low, and not really see a change in performance, because those things are only affecting the GPU. And then furthermore, even if you were to do something like enable DLSS or FSR, right, to get higher frame rates, you're not going to see higher frame rates because those features don't work well when you're not GPU bound, all right? So you need to have a fast enough GPU and a fast enough CPU in particular to feed that GPU so that you can get that flexibility, right? And we're seeing limitations on that. Essentially, the game looks like it's frame capped at a certain point. No matter what you do, it's not going to go above that, right? In some cases, it might even go below that, but yeah. So what are the biggest offenders we've seen in recent, out of that list I mentioned earlier? We saw this with Spider-Man Remastered, which I don't think is coincidental. That came as a PS5 port, and I'll get into more of that. We definitely saw this with The Last of Us Part 1 port, which as of March 2023, when it came out, many people were calling it the worst PC port ever up to that point, or one of the worst ever. We saw this with Gotham Knights in the fall last year. We saw this a bit with Forspoken. There's a lot of games, but probably the worst offender is the recent release of Jedi Survivor. I mean, this, again, now it topped The Last of Us Part 1, and many people were saying that this was the worst AAA PC port ever, or definitely of this year. And that's saying a lot. And we saw cases, there's a number of people, if you just look online, look at people gameplay. Shout out to Daniel Owen. I don't know if you'll ever see this video, but he's a YouTuber. He gives great commentary and kind of like hands-on impressions running things on his beefy system. But he and a bunch of others showed that Jedi Survivor, when it launched at least, you could, on a 4090 and a 7800 XD, I think those are the system he had, top of the line, fastest CPU and GPU out there. Literally, you could not hit a consistent 60 FPS at all with that game, even at lowering the settings to 1080p and changing the settings from ultra to low. in many cases, it still wasn't running at a consistent 60. And that's because it was just so horribly CPU bound and just not optimized at all. Not taking advantage of CPU at all. And it was sad. It's sad. I mean, again, you have thousands of hardware. You really reduce it to lower than console settings, and you couldn't hit 60 FPS. I mean, it was kind of like, okay, like what's going on? Obviously, that's more of the app, not a reflection of the hardware, but still, pretty sad. With The Last of Us, right? The Last of Us perf on PC, we saw that the hardware, like the PS5 equivalent hardware in the PC, right? Which is generally speaking something along the lines of like, a Zen 2, 3600, 3700, 8-core CPU, right? And then, generally speaking, a roughly 6650 XT AMD card or a 2070 Super to 2080 level, right? Roughly. If you looked at The Last of Us Part 1 on PC, that level hardware didn't come close to running at what a PS5 can do. PS5 is pretty easily 1440p, locked. That's native. That's not dynamic. 1440p 60, where it pretty much is an unwavering 60. It almost never drops throughout the entire game. So you can say that the 1% low is effectively 60, right? And that's what it is. And if you look at the PC, again, there are plenty of examples where to get to that level where you have a consistent, 60, 1% low 60, you're looking at something that's closer to a 6800, RX 6800 on the AMD side, and something closer to like a 3080 on the NVIDIA side. I mean, it's definitely beyond even a 3070 Ti. It's crazy. And that's like almost, double, the PS5 is running at almost double the performance of like a 6600 XT, for example. I mean, it's insane. And a lot of that is because porting games from PS5, and I said this before in other videos, is not an easy thing because the PS5 is pretty smartly designed, for one, and it has a lot of dedicated hardware to do work that on a PC you need to allocate resources on the CPU in particular and some on the GPU to do. So that gets into the bigger thing here. Why is this happening? Why are games coming out so CPU bound, right? And my take on this is that effectively you were noticing this happen a lot more with these quote-unquote next-gen games, meaning games that finally are not cross-gen. They're not releasing on the older PS4, Xbox One level hardware. The games where they're only released on the PS5, Xbox Series, and PC, right, hardware. No coincidence, right? And the thing is that previously a lot of the games on the last-gen consoles and just last-gen engines of that era, those consoles were extremely weak in the CPU side, right? That was their bottleneck. They had pretty decent RAM and pretty decent GPU, but the CPU was weak. So what that meant was that a lot of devs were making engines that were constructed in a way to minimize the CPU work, which is why we saw a lot of those games run at lower frame rates, have much lower simulation, and even some things that we saw back in the PS3 era in terms of like physics, destruction, animation, stuff like that. They cut that down because they didn't have the CPU to do it. Work with, in order to get any kind of performance, you had to split a lot of your work across multiple cores, right, and/or threads, which we saw with a lot of like the first-party console stuff, but a lot of the third-party stuff, they wasn't doing all of that. They just really used very light CPU work. So what happens now is that a lot of these engines are still being used for these quote-unquote next-gen games. They're just trying to go back and update the engines, right? But there's a lot more CPU work that happens today in modern games that wasn't happening 5-10 years ago, right? So the CPU has to do things like, decompression of assets on the fly in many cases. Ray tracing has people don't think about it, but it has a much larger impact on the CPU as well, right? To set up the data structures and such that are needed for ray tracing. And in general, we're seeing that the amount of assets and the complexity of the assets in terms of, shaders, materials, stuff like that are much denser. They're higher quality. Of course, the overall complexity of these games obviously are going up. Even animation, physics, etc., right? And world simulation stuff is going up. So the CPU is being taxed a lot more. And developers aren't taking the time to optimize, and in some cases really re-architect their engines around being able to, they have more CPU power now, right? The issue isn't so much that the CPUs are weak. It's just that the engine, the way they're constructed, aren't taking advantage of them, right? They're limited to like one core or in like one thread that's bottlenecking the entire CPU. Most of the CPU is idle. Cores are sitting unused. Look at the CPU utilization in Star Wars Jedi Survivor. It's not that the CPU is like 100%. It's never 100%. You'll see it in 30% range, but it's CPU bound because, again, none of the graphical settings work. For change of resolution doesn't work, right? And that, obviously the level GPUs you might have, like a 4090, 4080, it's underperforming. But the CPU utilization is like 30, 40%, right? It's pretty bad because they're not utilizing it well. Most of these games leave those cores underutilized, and the single threaded performance, single core performance is really the bottleneck. Now, consoles mitigate this, in particular the PS5, but even to some extent the Xbox Series. To some extent, right? They don't mitigate this completely, but in general, on the console, the CPU has much less work to do. They can just focus on working on the game, processing the display list for the graphics card, keeping the frame rate up, etc., right? On the PS5 in particular, there's dedicated hardware to do a lot of that work that the CPU is doing on PC. Things like, again, the I/O, data flow in terms of like how data is propagated through the system from the SSD, getting it into the GPU memory. There's a ton of dedicated I/O, hardware for that. We know that. Doing the decompression, there's dedicated decompression on the PS5, so the CPU doesn't have to do that. RT, there's some RT, customizations to help facilitate RT and some of that work in terms of the data structures and stuff like that. And then, again, there's a lot of just memory management type stuff that's customized on the PS5 as well to just make that stuff a lot more efficient. There's just a lot of work on data workflow and throughput on the PS5 that would fall on the CPU on the PC side, right? And the bottom line is, the resources are limited. Devs are just like, they don't either have the knowledge or most likely just the time, and the money and from their publisher that's saying this game got to ship. Like, well, we need to go in and there's a lot. This stuff isn't easy to do these optimizations and to re-architect your engine. It's a lot of work involved, and they just don't have it. And most of them are just like, well, we just need to create a new engine for our next game or something down the line, but that's going to take a lot of time. So this is a real problem. Like I said, no matter what hardware you have, it's effectively just limiting your overall experience and how far your PC can go. And in many cases, it can, in extreme cases, it can literally just be worse off than even a console can. So that's pretty bad. The next issue I'm going to talk about is VRAM and just memory explosion. The size of how much memory games are using is growing tremendously. We're seeing games use well over 20, 25 gigs of system RAM, and in some cases, approaching 20 gigs of VRAM, right? Like, I mean, it's pretty insane. In a lot of cases, there are like memory leaks where the actual memory allocation is, once you're running the game, it's increasing as you're playing the game. And that's been a problem because usually what happens is if you have a graphics card that doesn't have the memory, what's going to happen? It's going to crash, right? And we saw that. Last of Us Part 1 was probably the big culprit of this, but we've seen this before with Forspoken as well and a number of other games. But even Jedi Survivor has some of this. They're oversubscribing in memory and they're crashing. If you try to run The Last of Us on an 8 gig card, even though technically, it meets the requirements, the specs, after a certain point in time, you notice that the memory utilization and usage goes up, and at some point it's just going to exceed that, and it's going to crash. Not a good experience, for people that were running into this. Not a good experience at all. Well, why is that happening? Well, on the surface of it, it seems obvious. Like I said, PC games are just using a lot more RAM. Assets are larger. There's just a lot more data now, right? And system, that affects both VRAM and system RAM, right? But if you go a little bit deeper, if you notice, a lot of the time, most of the games that really hit this, again, no coincidence, are games that are really focusing on the next gen consoles, PC, PS5, and/or Xbox Series. And there's just next-gen only games like Forspoken I mentioned, Last of Us Part 1, which was a dedicated PS5 port of The Last of Us. Those are some of the big examples, but there's others too. But in general, what's happening is, without all of that dedicated hardware that I was talking about, right, on the PS5, and Series as well has some of this as well. The default way to handle, doing what modern games are trying to do is just to allocate more memory, right? Because the idea is that if you have a lot of highly detailed assets, if you have highly detailed worlds, and you want to be able to move fast through them and traverse fast through them or whatever, the default way to handle something like that is simply just to have it in RAM, right? Allocate more memory, put more of the level, put more of the environment, put more assets in RAM, and that effectively means that the system can access that data faster. Because if it's in RAM, RAM is faster than obviously a hard drive would be, and even in the SSD. So put it in the RAM, you can get to it faster. The problem is you're putting it in the RAM. So as you start putting more, think about some of these worlds where you want to have a whole bunch of the world accessible, because the new modern model and the new paradigm with these new systems, these new consoles in particular, is with SSD speeds to be able to read and write data, you can, stream in parts of the world at runtime and it'd be seamless, from a user perspective. You don't have to put it in memory, right, to preload it so you can access it fast. That's the way to make it seamless. Now let's back up. Back in the day, the way to deal with this was to have a loading screen, right? To load a separate level, right, or a separate part of the game. That was kind of the whole purpose of having levels. Even, in the 3D era, having these sections of games where you go into this, one part of the world to this part of the world, the game would stop, you would see a loading screen, it would pause. It's loading in the new assets for the new area, right? Nowadays, we're trying to be seamless. We're trying to get rid of loading screens. We technically have the means to do that with an SSD and the bandwidth that it has. If you do that, you still have to load this stuff though, right? Right? So if you have an SSD, again, with the proper, hardware and I/O, throughput, you can get data from the SSD into, the graphics card to display on the screen, near instantly. That's what the PS5 is the promise of the PS5 is. It's obviously would be a lot slower to do that if you had to do that on a CPU, for example. CPU is not going to be able to process and do everything that's needed to do that, decompress the assets and stuff like that on the fly without you seeing some impact of that. So the way to keep it seamless in general is, and the way to keep the data flowing the fastest is to have it in RAM. So with a lot of these games that are doing really, really fast streaming coming from the PS5 or the series, we see, again, Forspoken, The Last of Us, there's a lot of streaming involved in both of those games. Again, because that's what they focus on, trying to, show off and highlight the PS5. We'll see that a lot more too with some other, Sony ports that are going to happen probably down the line. But you have to allocate more RAM. It's that simple, and that's what we're seeing. If you look at the requirements for The Last of Us Part 1, all of the issues that we have to see in the game is right there if you look at it. So if you look at that performance mode, the 60 FPS at 1440p high, guess what? That is the PS5, right? That's the PS5 settings. Look at the GPU requirements. A 2080 Ti, 6750 XT, that seems way higher than what, right, on paper, a PS5 looks like. It's like, a 2080 maybe. Best case scenario, we're talking probably a 2080 Super. That's what I've been on record saying in the past. We're talking about system performance. There's more than just the GPU, right? There's CPU, RAM, etc. And then looking at The Last of Us, like I mentioned before, look at the real world performance on the GPU. Again, 1440p high, and yeah, we can see the what it looks like. And the reality is, the PS5 is running at 60 FPS kind of steady, is near locked. Let's say 1% is pretty much 60 FPS. So to get a 1% 60 FPS, you can see here, we're looking at something along the lines of a 6800, RX 6800, right? And even something above and beyond, remember, we're almost at 3080 level. So even above and beyond a 3070 Ti, which again, right, it doesn't seem like the math doesn't add up there. But that's again a testament to just how unoptimized the PC port is, and how hard it is to port those PS5 games that are doing certain things that don't necessarily map well to the PC, and you get a lot better utilization, from the hardware that is there on the console side, right? But that's a problem because people, you're spending the money for all this extra hardware on the PC side, and you're not really getting your money's worth, right? You're not able to really fully take advantage of, what that is. So that's a problem. The classic case in thinking about, the whole RAM and VRAM, explosion, as I was talking about it, is looking at Ratchet and Clank. Right now, that's a telltale game on the PS5. It's the poster child for, the SSD actually being used during gameplay, at least, right? You literally have the game streaming in whole other worlds, right? Doing runtime seamlessly in roughly a second, right? Where it's not even noticeable. And it's actually, while you're in the middle of the gameplay, the world can literally just change all around you. And the way they're doing that now with the PS5, again, they're taking advantage of the SSD speed, they're obviously taking advantage of all the dedicated I/O, and they're able to really fully utilize the bandwidth that the SSD has, that 5.5 gigabytes of bandwidth. Although that game isn't streaming quite that much, of course, but they're able to get a lot more out of it. The way that something like that used to happen would have been to have the entire world, right, in RAM. So the other world, both worlds. So the world that you're currently playing on, and then there will be like another world that you want to morph, or transition to. Both would have to be in RAM so that when the player actually triggers it, it can happen really, really fast and pretty seamless. So literally, you're talking about having two worlds in RAM. It's not very efficient. It's double the memory cost, and that's kind of what we see, right? The 32 gigabytes versus 16 gigabytes, right? That kind of thing. Now, you don't need to do that because the SSD is fast enough to really be able to just do that and dynamically do it. You can pull it, stream it, show it. If you need to transition again, you can pull another world so it can be even more dynamic. So yeah, you don't have a world where you have to have like 6 levels in RAM at the same time, which isn't really feasible nowadays. You can just have the character move around and you can dynamically, shift between those 6 worlds, using the I/O speeds, which is, that's the real innovation here, I guess, for this generation, although we haven't seen that happen quite a bit yet, right? But that's how the PS5 doesn't need to have, super high RAM, in terms of just quantity, if it's utilized efficiently, right? So that's kind of like the whole VRAM. I think we're going to see this happen a lot more. 8 gigabyte cards don't seem to be going anywhere, by the way, from NVIDIA in particular. So yeah, right? I mean, there's going to be some people out there with, relatively new GPUs, but lower end, entry level, mid range, that's not going to have 16 gigabytes, 24 gigabytes of RAM. And games are going to continue to use a lot more RAM. That's going to happen. Now, hopefully, when they start doing things with direct storage more and using like GPU decompression, that's kind of, there to somewhat emulate what, the PS5 and series consoles can do. We might see that mitigated a little bit on the PC, but in the nearest term, I would expect that we're going to see a lot more PC games have outrageous RAM requirements or just, NVRAM requirements, right? And we're going to see this continue to happen, I'm sad to say. Okay, so that's the VRAM thing. Now, the other technical consideration here is stuttering. And when we talk about stuttering, now this again is a game-breaking thing. It literally ruins the experience. It's not something you can power your way through, no matter what level of hardware you have. Unfortunately, you can still run into this. Now, there's two kind of, I guess, core types of stuttering that we've been seeing, and I'll break down both of them. The first one is the dreaded shader compilation stutter. Okay, now what does this mean? Well, basically, the game is trying to compile shaders that are needed for certain areas in the game, certain areas, certain levels, certain assets, etc. During runtime, while you're playing the game, is trying to load it in the background. The stuttering is happening because the loading isn't able to happen fast enough, essentially, right? And it's not able to load and compile the shaders, right, and actually use them So you run into situations where the game literally pauses while it's trying to finish a load. Or you just run into situations too, in some cases where, the certain parts of the environment don't look quite right because they still need to load the shaders, right? Compile and load the shaders. So why is this happening now, right? Shader compilation isn't new. Shaders have been around for, well over 2 decades, right? Well over 2 decades. Why is this happening now? Well, there's a couple of things here. First, why is it a unique problem on the PC? That's a common question. So let's understand this. On a console, the compiled shaders are necessary depending on the type of GPU you have. And it's even tied to like the driver that you're using, because that can change as well. So with a console, because it's a fixed platform and because it's a known entity, we already know exactly what GPU is there and what format the shaders need to be in order for the GPU to actually execute them, right? So developers are able to pre-compile shaders when they package up the game. So when you get the game and download it, the shaders are already there, right? Compiled. They're ready to go. So all the game needs to do is just the PS5 or series need to just, actually execute them at runtime. No problem. On a PC, because there's so many different GPUs out there, there's no way a developer knows exactly what GPU you will have. There's so many different people out there with different systems running the game. So they cannot pre-compile the shaders like that. They have to do it once the game is actually run. There's different times they can do it, and I'll touch on that in a second. But once the game is actually run, they have to detect what hardware it's running on, what GPU is there, and then say, okay, now I know exactly, what target I need to make these shaders run on, right? So there's a couple of ways to do that. One is you can load the and compile the shaders at startup, right? So when the game is going through the initial splash screens your first time through. Now keep in mind that when you compile a shader once for a particular piece of hardware, you don't have to recompile it every time you play, right? Or every time you go through that section. Once you do it once, it should be there, right? It's there. It's actually available to the game, and things should be fine. So it should be a one-time thing. This could change if you change your GPU. In some cases, it can also change if you actually have to update your driver. So yeah, you might have to run into it again, but generally speaking, it's a one-time thing. Just keep that in mind. So you can do this at startup before the user starts playing the game. That makes sense, right? You can do it during loading screens if the game has loading screens, which is a common thing. That's how things used to happen for a while. And then you also can try to do it at runtime, somewhat in the background, maybe during a cinematic, right? When there's not actually interactivity that the user is doing, that kind of thing. Now, historically, this goes back to what I said about loading, right? Games was divided into levels. So you would have a loading screen before the level. The actual environment was sectioned off, right? And divided into areas that, had similar things, so you can kind of load things in a similar way. In other words, the game wasn't seamless. And when that was happening, you would not only load all the assets, but you would compile the shaders. Now, like I said, we're trying to move to a world where open world design, world is completely seamless. So, we're able to load super fast with SSDs, but SSDs aren't helping with the shader compilation, right? The shader compilation is actually done typically on the CPU, right? In terms of actually executing that. So having the ability to load at, super fast speeds isn't helping that. Now we're seeing the level is loaded, right? There's no load screens in the game, but the shaders still need to be compiled, right? And that's work that still needs to happen. And in the world where, like I said, the CPU is already so unoptimized and overloaded in some ways, or bottlenecked, now you got to do shader compilation as well, and that typically is going to add to that bottleneck, and that's why you see the stutter, because the CPUs aren't fast enough to do it, essentially. You'll see more shader compilation stutter if you have a older, slower CPU, for example, than if you have a newer, more modern CPU, right? Just think about it like that. So why is this more of a problem now as well? Because it's typically, it used to be mitigated somewhat by the API and the driver, right? Up until DX11. So DX11 and earlier, and NVIDIA and AMD and Intel had their drivers, and in conjunction, they worked pretty well to handle the shader compilation process, right? There were things that the developer didn't have to worry about from a programming standpoint that was kind of abstracted out, right, and handled at the driver level and the API level, right? Starting with DX12, as many of you may know, a lot more of the onus is on the programmer, on the developer to do the work in terms of memory management, managing all your assets, managing your shaders and how they're loaded, and et cetera, et cetera. So with that, it's just more work. And obviously, depending on the engine and depending on the developer, they may not be the best. They might not have the best solution. They might not have the best code to do that effectively and efficiently. So you'll see situations where titles are pre-compiling shaders at a startup. You literally will load the game and you'll see a message saying, "Oh, pre-compiling shaders," but you still see shader compilation at runtime because they're not fully loading the shaders, right? Or pre-compiling the shaders. They're only doing it partially or something. Or in some cases, it's still a mystery why we're seeing this when in some cases they are pre-compiling shaders. It seems like a logical solution would be to always pre-compile shaders, but for some reason, some devs may not want to do that. Now, there seems to be an issue more so on Unreal Engines, particularly Unreal Engine 4, and that's largely because Unreal Engine 4 wasn't really designed at the time with the whole DX12 model of micromanaging all of your memory and shaders and stuff like that. It just wasn't designed with that reality in mind, I guess, right? So there's some under the hood things. I'm not going to go into all the technical detail, but there's some under the hood things that Unreal Engine 4 that does make it a bit harder for developers and a little bit more work for developers, I should say, to properly handle the shader compilation and try to do it in a seamless way where the user wouldn't see any impact from it. So we see it more on Unreal Engine 4 games, but it's not unique to Unreal Engine 4. Let me be clear about that. We definitely see shader compilation stutter on non-UE4 games as well, okay? But DX12 is a big part of the problem here. And let's look at the other side of the equation. The shaders are getting more complex, right? Games are getting more complex. Games are getting more realistic. Games are adding a lot more technology. They're getting bigger. Like I said, more seamless, etc. You got bigger, longer shaders to compile, right, and try to execute. And that means the work is going to be more. It's a burden on the CPU already. The developer has to do it, kind of manually now. So put all of that together, and it just comes down to, again, it's CPU dependent, so they could test their game running on a really fast CPU, an Intel 12,000, 13,000, but you might try to be running on an Intel 9,000. And guess what? With everything else going on in the game, you're CPU bound, shader compilation is going to be a much bigger issue for you, right? So everyone may not see it equally is what I'm saying. That's the nature of the PC. Some people might say, "Oh, I don't see it at all." Some people might say, "Oh, it's a little bit here and there." And other people are saying, "This is completely unplayable. It's like a slideshow," right? And that's why, okay? So again, loading, great. SSDs, great. Shader compilation problems not fixed. Unreal Engine 5 is trying to help out with this quite a bit, so hopefully that will help and make it at least a much less of a problem. But there's other stuff there that, again, that has to go back to the API driver level and just ultimately the software as well to really, really fix this. But hopefully we'll start seeing more developers pay more attention to this. So that shader compilation stutter, we saw this in a bunch of games recently. Digital Foundry highlighted this in a bunch of games, including Callisto Protocol had some serious shader compilation issues, I remember at the time, and they definitely called that one out for being a really bad offender. But there was a number of games that ran into this. The other type of stutter is traversal stutter or runtime stutter, I'll say. So this is kind of stutter that's more due to loading new assets, right? So you have to load in a new area, right, of the scene at runtime. In some cases, again, whether it's an I/O issue, whether it's a hard drive or SSD issue, or whether it's a CPU bottleneck, again, this is more work on the CPU. But somewhere along the way on certain systems, something may not be quite fast enough to get the data where it needs to get, right, based on how the engine is set up, right? So as you try to traverse, and again, the games are moving in a direction where traversal is meant to be super fast, super fluid, right? Assets are meant to be streaming in really, really fast, seamlessly, high resolution, highly detailed assets at that. Lots and lots of data that need to shift around the system during runtime. And if any one of those areas are bottleneck, like I said, CPU, hard drive, I/O pipeline, etc., and data doesn't get to where it needs to be, guess what? You're going to see that manifest as a stutter, all right, a literal pause in the gameplay. The biggest example I can think of where we saw this on the PC is Returnal PC. Now, most people think Returnal PC was a great port. It's actually one of the exceptions, especially considering it was a direct PS5 port. Overall, they added ray tracing, right? Performance looked pretty good, blah, blah, blah. I tried Returnal when it first launched on the PC. I had it on a 3080 system and I had it on a 4090 system. And in both cases, with RT on, the stutter was absolutely unplayable. It was horrible. No matter how fast it was running on 4K, blah, 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 it doesn't matter. It was unplayable. Because literally every few seconds my game was stuttering. And it wasn't shader compilation stutter, because that would only happen once. But as I was trying to go through the environments, every time I went to another room and was trying to traverse, it would just pause and stutter. It was really unplayable. I'm not saying it's like that today. I know they patched it up a bunch of times or whatever. I haven't tried it. But it was a far cry from the smooth, the PS5 experience, even though it technically looked better than the PS5 version. But it wasn't playable in that regard. Now, Returnal on the PS5 is using the SSD and that I/O pipeline quite extensively. The game is procedurally generated like rooms. And when you play the game, you actually move through them pretty fast. Like the actual character movement is fairly fast. It's really dense. There's a lot going on, a lot of enemies, particles, etc., etc. But they have like these actual doors, right, to each room that's procedurally generated. And on the PS5, those rooms are streamed in dynamically. When you are playing the game, there's no stutter, there's no pause, there's no loading. You just seamlessly are running around. You get to a door, the door like opens, and the other room is there, and you're good to go, right? And it's actually pretty cool, right, to see how smooth that is. So on the PC, they're not using direct storage yet, because direct storage, I guess, wasn't really quite a thing yet by the time Persona came out on PC. But, you can brute force your way with a really fast CPU to do a lot of stuff, but apparently not fast enough, right? So, again, playing on an SSD as well with RT on, it was just stuttering a mess and it was, like, as I traversed, as I got to a room or just after I entered the room, either right before entering the room or during the process of like the door opening or right afterwards, the game would pause and stutter. And it just happened throughout. There's objects and enemies that kind of spawn in and stuff like that. Somewhere along the way, it was just stuttering like crazy. So that's an example of what it could look like. There's a lot of games that run into, Jedi Survivor recently had some traversal stutter on PC as well. Just running around the environment, just trying to stream in something and something is bottlenecked. Again, it's easier to do this on the console because it's just fixed. So you know what it is, so you can, optimize your code to work with whatever that is. PC, there's other variables at play that developers can't always account for, right? So that's traversal stutter and that's stuttering in general. So those are the technical issues. They are numerous. They have been, definitely impeding on our ability to enjoy these games on PC, no question about it. And hopefully, we'll see them get better. There it is, guys. I mean, that's kind of my assessment of what's wrong with PC. I mean, the main things, I should say, that's wrong with PC gaming today. It's unfortunate. A lot of people are saying this is the worst time for PC gaming. This is the worst year for PC gaming, these kind of things. I want to see it turn around. There's some great games in the pipeline. There's great technologies out there available, for PCs as well as consoles and whatever. I mean, just gaming in general is great. So hopefully we can get this stuff, sorted out, right, as an industry and pump out some good quality polished games. So we'll see what comes later in the year from a lot of the other, the bigger games still to come. We'll find out more, I'm sure, over the summer around the E3, all of the showcases and stuff like that is about to happen in the next month or so. We'll find out. But that's all for now. Appreciate it if you made it this far. Let me know what you think. Again, PC gaming, where are you at? How are you feeling? Am I right? Am I wrong? Am I, kind of making sense here or not? Let me know, please. Like, subscribe, help me grow the channel. I appreciate you guys. Till next video, True Techno Gamer signing off.